First, I'd like to talk about limits on human performance. So as athletes, we have limitations, of course. One of those limitations being muscle fatigue. As we do long distance exercises or high intensity exercises, we put strain on the muscles and on our bodies. Another type of fatigue that as athletes we need to overcome is psychological fatigue. I'd like to first talk about how our muscle fatigues. So our muscle will fatigue through continuous contraction. So as we do a sport such as running or swimming for an extended period of time, our muscles will eventually become fatigued. So when we want to contract a muscle, for example, my bicep, when I want to contract it, my brain will send a signal through a neuron, which will release neurotransmitters, and it will tell the muscle cells to contract. Okay? There's several different types of muscle contractions. There's isotonic, and then there's isometric. So isotonic, there's two types. There's concentric contraction. For example, bringing the bicep closer to my body, you're contracting the muscle, it feels really tight. And then there's eccentric contraction, lengthening the bicep, bringing it further away from the body. Isometric, an example of that, isometric contraction would be flexing my bicep but holding it in place. Through long distance exercises such as running, there's eccentric loading on the hamstrings during running, and this causes a lot of fatigue and a lot of inflammation to the muscle. The negative side effects with endurance exercise. Endurance causes muscle fatigue. As our muscles fatigue, our performance will go down. First is our muscle becomes tense. Blood vessels start to compress, and then the blood flow eventually gets worse as we run. Fatigue factors accumulate, and stiffness and pain occur. This is why after you go for a jog, afterwards you feel fatigue and you feel that pain and stiffness. It's because of this process. There's also increased likelihood of muscle trauma as we continue to do these various types of exercises. There's a lot of stress on our body, and our body can get injured, or typically we just become fatigued and muscle fibers break down.
And about what causes inflammation, we saw two main factors. One was the introduction of PGE2, and with increased PGE2 in our blood and in our cells, we're going to see an increase in macrophages and cytokines. Macrophages and cytokines are both pro-inflammatory, so these two factors here can increase the inflammation that we experience as athletes. With this as well, and this is also the reason why Josh pointed out, after we go for a long run or after we do a lot of intense, long distance training of any kind, we experience a lot of muscle soreness or pain 24 to 48 hours after that training or after our workout. The reason why this occurs, if we go back to this slide right here, is, as Josh talked about, right? As we contract those muscles, it cuts off a lot of blood circulation to those major muscle groups. When our blood flow decreases, we have blood pulling up with all of these cytokines and macrophages involved. And if we can't get those out of there, then our muscles will tend to stay inflamed for longer periods of time. So what we wanted to do as researchers is we wanted to see if we could help our athletes out with the roadblocks of inflammation and fatigue and the pain associated with that, because those are some of the limiting factors that athletes experience with their training and their competing. So the supplement that we wanted to look at in order to help with this is creatine. Now, creatine is one of the most studied supplements out there on the market and one of the most commonly used supplements among bodybuilders, athletes, fitness influencers, all throughout the world. Now, we already know a lot of the benefits of it because it's been so heavily studied. Let's just go through a couple of those. So we know that creatine is shown to improve muscle performance during short bouts of time. So this is quick bursts of energy. So sprinters, weightlifters, right? Especially as they're about to go for like a max or a personal record, right? Creatine is going to help them get that energy that they need to lift the weight that they need to lift. In addition to this, it also helps with high intensity. So again, like those sprinters, they need that quick burst of energy for that high intensity run. On top of that, a couple of other benefits that we see is that creatine increases glycogen by 40%. What that means is glycogen is another source of energy that our body uses. It can break it down, turn it into ATP. We know that ATP is the source of energy for our body to do work. On top of that, we know that creatine increases weight gain. The reason for this is not due to fat, but what it does is it allows our muscle cells to absorb more water into them. Bodybuilders love this because what this is going to do is make their muscles seem fuller. It's going to make them look thicker, bigger, right? On top of this, we also know that creatine is going to help maintain muscle integrity as well as reduce muscle damage. And that one is a big one that we look at as researchers because fatigue and inflammation can lead to muscle damage if it's not taken care of or treated properly. So with this as well, let's take a look at specifically how creatine works and the process. So as I talked about earlier, the body uses ATP for energy. When our muscles contract, they use ATP and they turn ATP into ADP. ADP can no longer be used as an energy source until we can put another phosphate group on it. This is where creatine comes in. Creatine helps our body turn ADP back into ATP. The more ATP we have, the more energy we have to perform work. It allows us to lift weights more. It allows us to run longer. It allows us to exercise for longer, train longer, which allows us to compete better. On top of this, as researchers with our study, we wanted to see if we could do anything to help our bodies better utilize creatine. So a couple of things that we found. If we regularly exercise, this helps our body utilize that creatine that we are supplementing with. If we are not exercise regular, then our body is not going to be as capable of utilizing creatine in our system, especially since creatine is a naturally occurring amino in our body. On top of this, we also found that taking a carbohydrate drink with our creatine allows our body to better utilize the creatine that we're supplementing with. Carbohydrate drinks are just like sports drinks, something with some simple, quick sugar that our body can utilize. And so with our basis of how muscle contraction works and creatine, this leads us into our actual study about what we did. And James will be helping us through that.
Start out, we got a bunch of marathon runners basically, and we had them do 90 kilometers of cycling, 21 kilometers of running. Our methods were, so we split them up into two groups. We gave half of them creatine and half of them a placebo. To start off with how we gave them the creatine, we didn't just hand it to them. So we had to do what's called a loading phase. So to start it off on the loading phase, for 5 days, they did 20 grams of creatine every day for 5 days. After that, so this was just to get their cells saturated with creatine, so that from there we could just do 3 to 5 grams a day, just to continue with the saturated cells. As I said, we did the 90 kilometers cycling, 21 kilometers of running, and then we measured their cytokines in their plasma 24 to 48 hours after.
Also, we measured pain, if they were in any pain after, and how much pain, as well as muscle stability throughout the race, how well that the ones on creatine could do in the race, and how well they finished versus the ones that weren't on creatine, on the placebo. Here's to begin some of our results. We found that creatine actually increased muscle stability. So those who were taking creatine, the group that wasn't on the placebo, they were able to perform better and less injuries, as well as lessen muscle pain and weakness. Specifically in what we were studying for the 24 to 48 hours later, during those periods of time, the placebo had much more pain and much more muscle weakness a day or two after. The ones on creatine had much less, and this is something we're going to get into next in just a second. Okay, one thing I want to talk about is some of the cytokines that we studied. So TNFA and PGE2. So PGE2, as we talked about earlier, was the main thing bringing macrophages into inflamed muscles, causing more muscle soreness, muscle pain. And TNF2 was one of these cytokines that introduced PGE2, as well as a cytokine called IL-1B. So these are all pro-inflammatory cytokines, and they were going to cause more inflammation in the muscles after this long-distance eccentric exercise, which caused more pain. You see here TNFA and IL-1B were just some of the ones that increased PGE2. And they did it in endothelial cells, smooth muscle cells, and skeletal muscle. So this next one that we want to talk about, this next cytokine we want to talk about is called IL-6. Now it's actually not a negative one. This is one of the positive ones that we are also studying in our plasma naturally as well. But we found that those who took creatine had an increase in IL-6 after 24 hours. But more importantly, it maintained and even raised blood glucose levels. So this is obviously important because they just ran the 90 kilometer cycling and 21 kilometers of running. So they were pretty drained of blood glucose levels. So this actually helped them being on creatine, but also it inhibited TNFA production, which, if you remember from before, TNFA production increased PGE2 in the plasma, which increased muscle pain, muscle inflammation. Something also interesting, it was a protecting agent against disorders like type 2 diabetes. So here's some graphs for what we did. So this is first one, PGE2. So this side is those who have creatine, and this is the group that has creatine. This is the group that has the placebo. If you look here, so this is before the race, 24 hours after the race, and 48 hours after the race. So before the race, this is what the normal, it's the same for PGE2 levels in the plasma. 24 hours after the race, the ones who took creatine barely had a rise, if any at all. But those who didn't take the placebo had almost 5 times higher 24 hours. 48 hours after, some of the runners 48 hours after who took the creatine, some of them, if you look here, had even less PGE2 in their plasma than they did before they started the race. But those who were in the placebo group had some even over 6 times as much. This next graph is going to show TNFA, which is going to, if you remember, TNFA increases PGE2. But those, same trend, those who took creatine had much less, and those from the placebo was almost double. Yeah, almost double those who had creatine. So INFA, this is same trend. This is just another one of the cytokines that we were studying. It had almost double for the placebo, and then the ones who were on creatine had much less, which this is just one of the main reasons why we noticed that those on creatine had much less muscle pain and muscle weakness 24 or 48 hours later. Same thing here, IL-1B, much less on IL-1B, much more on the placebo group. Okay, this one is important, IL-6, if you remember before. The IL-6 cytokine was the positive cytokine that we were studying, helping with type 2 diabetes, increasing blood glucose levels, and lowering the PGE2. But if you notice, those who took creatine had much greater IL-6 in their blood or in their plasma than the placebo. And so it actually increased the non-inflammatory cytokine.